All right, guys, so I'm going to go over the review here. So you can skip around, go to a problem that you need help with, pause me, whatever. This is just for you as another resource. So the first question is asking you to find some information based off of this equation of a parabola. So just a reminder, if it is y that's the term that's squared, that means that your parabola is going to be horizontal. So a couple main things from here. You have your vertex. So just remember that x always comes first. So this would actually be +1 and then -2. And then always helps me to just make a little sketch. Okay, since this is negative, I know that my parabola is going to go left instead of right. Okay, so then the next part would be finding the p-value. So I have -28 equals, remember that always equals 4p. So if I divide by 4, that means that p is -7. Okay, and that negative is just telling me that it's going left. So then remember that p-value tells you the distance from the vertex to the focus and the directrix. Okay, so the directrix is always going to be outside, 2, 3, 4, 5, 6, 7, outside the parabola, so right here. So that would be the line x equals 8, right, because it's 7 units away from that vertex. And then the focus is always inside, so again, 7 units away. So 1, 2, 3, 4, 5, 6, 7, right, and then right there. So the focus would be at the point -6, -2. Okay, so that's number 1. Second one is an ellipse. So again, if you didn't know, just that plus sign tells you that's an ellipse. So the center of this one would be at, x always comes first. This would be at 6, -2. Okay, so let me plot that. All right, since this one has the bigger number under the x, right, that's going to help me find my vertices. That means this is going to be a horizontal ellipse. So 1, 2, 3, 1, 2, 3, right? This means a squared is 9, so a is 3. So this means that b squared is 4, which means b is 2. So those are my co-vertices. So that would be up and down 2. So this is kind of a small ellipse, something like that. Okay, so I already plotted it. So my vertices would be at 9, -2, and 3, -2. Co-vertices are at 6, 0, and 6, -4. Okay, then the only other part is the foci. So with an ellipse, remember that c squared equals, since this is plus, it's a squared minus b squared. So it's the opposite of what the equation says. So I don't know c, but I do know a squared and b squared. So that's 9 - 4, which is 5. So that means c is the square root of 5, technically plus or minus. Okay, so thinking about where that goes, those are always in line with the vertices. So it's a distance from your center. So plus minus square root of 5, right? It's gonna be a little bit bigger than 2, probably somewhere about there. So when I go to write that point, it's 6 plus or minus the square root of 5, right? Because I'm going right or left, square root of 5, and then it's staying on that y value of -2. All right, number 3 is just a matching question. So, you know, you have a hyperbola, so they should all be minuses, which they are. Just process of elimination, since this is a vertical hyperbola, that means that you should be having y squared first. So I can immediately get rid of the x squareds. Okay, and then the a value should be from the center, so 0, 0. They do all have a center of 0, 0. The a value should be 5. Okay, so then the equation that would have an a value, remember hyperbola a always comes first, would be c. All right, number 4 is asking you to graph a hyperbola, but this one's going to require us to complete the square first. So just start by gathering your terms. Something kind of like this. And then I'm just going to move that 11 to the other side, so we add 11. Okay, now we want to do the completing the square part, so x's are fine. I'll add my blank. Now for this part, we can't complete the square unless the squared term is by itself. So I need to factor out this -4. And then that would be y squared. Now this should be plus 2y, right? If I multiplied that, that'd give me -8y. And then I'm going to put my blank in here. Okay, so I have 11 and then 2 blanks. So we just have to fill in our blanks. So remember, this is 6 divided by 2 squared, so that'd be 9. Okay, so I did just add 9 to that side, so I'll do it to the right. And then this is 2 divided by 1 squared, so that's just 1. But you have to be careful if you took something out. I didn't actually just add 1, I did -4 times 1, which is -4. Okay, so now I'll go to my factors here. So this is x plus 3 squared minus 4, and then y plus 1 squared. Sorry. And then if I add everything on the right side, that would be 16. Okay, and then I want everything to be equal to 1, not 16. Sorry. So this is where I would divide everything by 16. Run out of room here. All right, so I end up with x plus 3 squared over 16 minus, this is going to simplify just to be a 4 on the bottom, y plus 1 squared over 4, and then that equals 1. Okay, so that would be your equation. So from that, you can get your center, which would be -3, -1. Okay, let's plot that, -3, -1. And then your vertices are going to come from that a value. So remember, hyperbola, a always comes first. So this is a squared, which means a is 4. Okay, since x is coming first, that tells us this is going to be a horizontal hyperbola. So from there, I have 1, 2, 3, 4 to the right, 1, 2, 3, 4 to the left. So I can get those points down. That's 1, -1, and -7, -1. Okay, if you're going through the whole motion of graphing, I think this doesn't necessarily say to graph, but we could graph it. Then your b value, we also got in our equation. That would be 2, so that'd be up 2, down 2. You could make your box. Right, you have your asymptotes from there. And here's your hyperbola. Okay, so that's kind of a big question. All right, number 5. So write the equation of the ellipse with center at 1, 2, and vertices at -2, 2, 4, 2, and covertices at 1, 3, and 1, 1. Okay, so make a sketch. So center is at 1, 2. Vertices are at -2, 2, and 4, 2. Okay, so if I know those are my vertices, then this is going to go this way. Right there with my center, I could start to kind of write my shell. Ellipse, I know I'm going to have a plus. I know it equals 1. I just have to figure out my A and my B. Right? You always need your center, your A, or B. So center is at 1, 2. Since this is going horizontal, well, ellipse x is always going to go first anyway. So x minus 1 and then y minus 2. Okay, since it's horizontal, I know my a value is going to go first. So I just have to figure out what that a value is. So that's that distance from the center to a vertex. So that's 3. Now remember, it's not 3 that goes in the equation. It's 3 squared, so 9. Okay, and then it also gave us the covertices at 1, 3 and 1, 1. Picture is pretty good. So that's your B distance, which is just a distance of 1. So 1 squared is 1. And that's it. Okay, so remember, you just always need your center, your A, and your B. Oops, there's 2 number 5s here. Okay, next one. Find the equation of the circle in standard form and state all of the information. Okay, so again, like the other one, first thing I would just gather everything. And I'm going to add the 36 to the other side. All right, for the x's, I can take a 6 out. Add in my blank. I can also take a 6 out for the y's. Add in my blank. And then I added 2 blanks on the left, so I'll add 2 blanks on the right. All right, so negative 2 divided by 1 squared, that's 1. But I didn't add 1 to the left, I actually added 6. And same thing with the y's. 6 divided by 2 is 3 squared, that's 9. But I didn't actually add 9, I added 6 times 9, which is 54. So I have 6, and then this would be x minus 1 squared plus 6, y plus 3 squared. If you add everything over here, I believe we get 96. Okay. Now, thinking about what we need, we want a circle. Circles don't typically have coefficients in front, so I don't care that it equals 1. That's hyperbolas and ellipses. So I'm not going to change the 96, but I do want to get rid of these 6's. Okay, so I'm going to divide these by 6. So I'm going to divide that side by 6. Okay, so I'm going to bring this down here. So I get x minus 1 squared plus y plus 3 squared equals 96 divided by 6 is 16. There I have my equation. So from that, my center is at 1, negative 3. Remember the equals sign, that's r squared. So my radius would be 4, not 16. Circumference is 2 pi r. R is 4, so that's 8 pi. Area is pi r squared, so it'd be 16 pi. Okay, so from your center, you can go up 4, right 4, down 4, left 4, and you got your circle. All right, find the equation of a circle whose center is 2, negative 1, and contains the point negative 1, 1. So you have your center, right? But you need the radius. So if you need the radius, remember that is the distance formula. So remember that looks like this. So it doesn't matter what you call what, 2's and 1's, but we want to subtract. So I could do negative 1 minus 2 squared plus 1 minus negative 1, so that's plus 1 squared. That's negative 3 squared plus 2 squared, 9 plus 4, so I should get 13. Now that would be the radius, but I want radius squared for the equation, so that would just be 13. All right, number 7, write the equation of the hyperbola in standard form and graph. So again, here's another completing the square one. So this only has one squared term. So remember, gather those terms on one side. And then for hyperbola, we want to move everything else to the other side. I'm going to actually put my blank right here. I have 4y minus 1 plus whatever I'm adding to the left. 10 divided by 2 squared, that's 25. So I'm adding that to the right as well. That's x plus 5 squared. This would be equals 4y plus 24. Now, remember for a parabola, we want that p-value, so I'm actually going to take that 4 out, and then this would be y plus 6. And that would be my equation. Okay, so that's going to go right here. Now I want to graph it. So my vertex from that would be at negative 5, negative 6. Right there. Okay, since that p-value is positive, I know that this is going to open, since it's x squared, it's going to open up. We need that p-value, so it's 4p equals 4, so p is 1. So my focus is just going to be 1 unit inside the parabola, so that's the point negative 5, negative 5. And my directrix is 1 unit, away from the vertex. So horizontal line, that's y equals negative 7. Okay, so it's a parabola. Next part is just classifying the conics. So this is the last thing we talked about. So just remember, you're looking for like what's squared and what are your terms. Oh my goodness, sorry. So like A only has x squared. So if there's only one term that's squared, that's the easiest one probably. That's a parabola. It'll stop working. The second one, so I have x squared and I have y squared. But the terms are different numbers and they're different signs. So if they're different signs right away, then I know that that's going to be a hyperbola because I would have a minus sign in it. Okay, on C, I have y squared and x squared, and they have the same term in front, so that is a circle. And then for D, I have x squared and y squared, both the same sign. So it could be a circle or an ellipse, but they have different numbers in front. One's a 1, one's a 9. So that's an ellipse. Okay, and that's it. All right, thank you.